Okay, so we're going to continue with lab. We're going to go into lab 2A today. So we're a little bit off sync until I think the President's Day holiday, and then we'll sort of be back on the regular pattern, I think, or maybe after test one. But lab 2 is where we're going to learn about this new data structure. The first data structure we're going to make on our own, but we're not going to make it today. We're just going to use it. Oh, hey, Ben. Ben's here. Were you here over earlier at 2? Okay. Did some folks show up? Oh, good. Yeah. You can get help if you're stuck on anything with Ben before class over in, was it 207? Yeah, or in 207. So you can look for him next week. He's only here on Wednesdays. Unfortunately, yeah. But yeah, next week we're going to do stacks, and you know, it starts to get a little more complicated, and it's going to get really complicated pretty soon. So today we're gonna just introduce things a little bit gradually, and yeah, it's pretty good. The lab is here. Maybe I should, let me see, what should I do? I'll pull it up anyway, because I will eventually want to show that to you. This is one of those things that you probably can't do this without checking out the lecture, because this is going to start getting into some new territory. So I'm going to hand out the lab just so you have it. I'm going to lecture for a little bit and then get you started, and then I'm going to run off to a curriculum meeting that I need to sort of chat with some folks about, while Ben can kind of cover the class. Yeah, and then I'll come back and do the second part of the lecture. We're going to look at bags and inheritance. These are two rather big topics, so rather than just lecturing all the way through, I'm going to get introduction to bags, and then we're going to go over inheritance, which is actually fairly complicated. Some of the topics are getting a little involved. So so that's the plan for today. So we're going to start with an overview of what this thing called a bag is. And well, just a kind of a review of lab 1 both parts. The first part, grocery checkout problem, we as you know, we used parallel. We call this parallel arrays because you have two arrays that sort of are in parallel to each other. So the first item of the first array corresponds to the cost of the name of the item in the first array of the names array. And that was one way to solve a problem without using your own classes. And when you create the arrays, it looks like that, knowing that doubles are stored inside the array cells, but objects like names, strings are stored outside, and you're getting references to those. So that's the model. And then with grocery checkout 2, did anyone not finish grocery checkout 2 yet? A couple people still working on it. You can ask Ben for help at some point too. But probably wait and do the first, do the bag thing later, and then you can always get help too if you're stuck on one of these things. You can zip up your project folder and email it to me. You might even try copying Ben if you want. I should put your email address on the website, so you can copy him too if you want to get his input. He might be able to respond faster than I can sometimes, or maybe all the times. I don't know. Anyway, we set up an array of items, and now the items are stored grouped together. So each object is stored with the name and the cost in the same location. So that makes it easier to find things. And the syntax is a little bit different, so you have to kind of be comfortable with that. But that was sort of an introduction to classes and arrays and everything. And now we're going to see how a bag can help us out. A bag is another way we can store these things. If you don't like storing items into an array, you can store them in a bag. And we're going to look at why that can be an advantage, what you can do with bags, and why they're better. And in fact, oh, by the way, before we get too far, I've reactivated homework 1 because some people were asking about that. And Ben has made some progress on doing an auto grading thing, but it still needs us to kind of mess around with a little bit. So, so homework 1 is available. It's not due until February 18th, but what I've done is I've disabled the submission thing because assuming we get Ben's setup working, you'll be able to submit your code and it will automatically grade it for you. This is like I've been dreaming about this for 18 years, ever since I started teaching, a program that could grade your programs. That would be awesome. And we're really close to having something to kind of beta test. So I'm just, you know, you can get started on homework 1, and you should get started on homework 1. After today, you'll have pretty much everything you need because homework 1 involves working with bags and arrays. And it's available here. There's a download. You can just start with all that. But you can't turn anything in yet. So early birds, just be patient. And then if we get it working, we'll share the submission for the auto grading thing so that you can turn it in that way and see how that works. Pretty excited about that. But yeah, it uses bags and arrays, so it's going to take us up to pretty much today's lecture. What is that? Yeah, so back to bags. So reading quiz. It's not a bad idea to thumb through the chapter before class because it will make more sense that way. It's a recommended technique for improving your learning in lecture. Assuming somebody might have done this or just using your own intelligence, what is not a characteristic of a bag object? What do you think the most likely answer is? B, there's no reason why items in a bag should be arranged in a ring, is there? No. So yeah, a bag is a finite collection of objects. The items are stored in no particular order. We don't really necessarily care what order things are in the bag. That's why it's called a bag. It's just like you just throw stuff into it, right? And our bag class can contain duplicate items if you want to store, which kind of makes sense if you're maybe buying a lot of items of the same thing in an online shopping scenario. The bag would be a good resource to hold those things. And so we're going to look at what this bag thing is and how it behaves, and then a little bit on the principles of abstract data types and everything. So you're supposed to understand a little bit more about abstract data types. We talked about abstract data types. What is an abstract data type again? It's kind of like a class, but it's sort of like a class is actually would be something that you wrote in a particular language like Java or Python. But an abstract data type sort of transcends the class. It's a description for a class, right? Is that what they tell you over at CSUMB? Yeah.
It's a conceptual model of how to organize your data nicely.
Yeah.
In a specific way. So certain operations.
Yeah, and it's actually kind of a design tool, so you don't have to bother actually writing any code while you're laying out really complicated object-oriented projects. You can just lay out the abstract data types, and what actually people do like really complicated software projects, they'll put like a lot of post-it notes on the board, which will sort of lay out the various objects in a particular problem, and you can draw linkages between them, and you can just sort of think it all through that way before you write any code at all. Because there's a lot of design work that needs to go in before you can actually write your code really effectively for really complicated projects. And I read, this is sort of an aside, but I was reading this one article on like the use of LSD when it first came out. And even now, I think some programmers that are working on really, really complicated projects, because the mind can only comprehend so much. Sometimes they take like LSD. You shouldn't do this. And I would never do this. But it allows them, they'll do this and they'll get the whole thing in their head, they can see it all, and then they can actually come down. But you could just use a whiteboard instead. Probably better for you to just use a whiteboard. But yeah, these are tools for dealing with complexity, and things are getting more complex. And so we're going to learn how to use these because they actually make our life a little bit easier, a lot easier. So a bag is a finite collection of objects, no particular order, may contain duplicates. So suppose you have this bag object. This is how you actually set up a situation with a bag. We're going to call our bag object a bag. And you've all pretty much used array lists already in 10A probably, right? Take the Java class. Then you know what this does, right? This tells you what? Sorry? Do you not know what that does? Yeah, it shows, it restricts the information you can put in the bag. So you're saying that a bag is a bag that's only going to be able to hold string objects. So if you try to put like a number in it or an item or a name object, you'll get an error, and it'll be a compiler error, which is helpful, again, when you're working on a really complicated project, so you don't do something you didn't think about or didn't want to do. So it's a little restrictive syntax checker thing to make sure you're using it properly. So you set up your bag object as a new bag of string, and this is a default constructor, so empty parentheses. Then you can start adding strings into it, right? So, and there's an add method that allows you to just keep adding items to the bag, right? But then the question is, well, what can you actually do with a bag object? And what kind of behaviors do we need a bag to actually implement? And this is sort of where the abstract data type design comes in. Right? Maybe we need to know how big, how many items are in the bag. Maybe we want to know whether the bag can hold any more items, if it's full, or if it's empty. Maybe we want to add and remove objects from the bag, or count how many occurrences of a particular item are in a bag, or test whether a specific item is in the bag at all. Or maybe we just want to actually just see what's entirely inside the bag all at once. So these are the kinds of behaviors that would be useful for a bag as a way of representing a collection of objects. So as we design the class, you can start listing these things out. And another design tool is this thing called what's a CRC? Class responsibilities and collaborations card. The 3x5 note card you can do, the name of the class, what's the responsibility for a bag, what it's supposed to do, and then what other classes it might collaborate with. Sometimes classes need to actually have pre-programmed interfaces with other classes so that they can work properly together. But it's just another design tool. Now, as you're specifying the class, you get to make some interesting choices. If you were designing a bag yourself, you don't have to choose the same way of doing things we did. But as you're defining the class, at some point, you're going to have to define what the name of the methods are that are going to do all these responsibilities that you list here, right? It's a design process. Initially, you don't really know what to call these things, but you're going to want to get the number of items currently in the bag, maybe, or you want to know whether the bag is empty. So these things are all going to become methods, which you have to name and provide arguments for, and prototypes and all that stuff. Parameters, what's the return type, and write the comments. You can write all that stuff out before actually coding up those methods. And then along the way, you might realize, oh, I've got to actually figure something out here. So if the bag only can hold a finite number of items, what should the add method do when we're actually can't hold any more items? There's a few choices you have to make here. There's a few options. You could do nothing, and just you can just keep adding stuff, but nothing goes into the bag, right? Would that be a good idea? Well, some programmers might find that a little confusing if you can do that, right? You could just not change the bag, but maybe signal somehow that the bag can't do that anymore. A common way of signaling that situation would be an exception. In general, you have to think about for all of your operations on a bag or methods that you're going to write, you know, what are you going to do when some unusual situation happens? These are things that programmers have to wrestle with when they're actually writing code. You have to really think about, you know, and quite often you know, the place you're working for may just sort of hand you something like this and say, here, go ahead and make me a class that does this, right? They haven't really, the people that are handing off the work to you might have not really thought of all the possible ways things can go wrong. But as the developer, you're going to have to think about those things, right? So, so some options we can do, you know, we can ignore these things. We can try to figure out what the client really wants to do. That's really like reading their mind. That's really hard to do. Return some flag value or return some Boolean value. And what we're going to sort of stick with is this notion here because it's fairly easy to understand. We can make our add method return a true or false, whether it was successfully able to add something to the bag. Or so that we can check that each time we try to add something.
Essentially, we something called optional, around the large language.
Oh yeah, huh?
And so it's kind of like a combination Boolean and then a type and then a thing.
Okay.
So you can have a function return an optional string, for instance.
Yeah.
And then you can check if there's a string, and if there is.
Oh God, that is so crazy.
Yeah. So
I'm never going to put that on here. I don't want you guys to worry about that.
It's one way. It's another way that you can sort of design.
So a method could return either a string or like an integer.
That's a different kind of thing. Yeah. That's like
Yeah, yeah.
An optional is exactly for this kind of thing.
Huh, interesting.
And it's like in Java, it actually is a specific class.
Yeah.
Like an optional class.
I see. Yeah. Cool. And another option is to throw an exception, and we're gonna. That was sort of the last cool thing that people came up with for doing these sort of things. We're gonna discuss that later in some interesting examples that take place. Exception handling is really good for like file reading operations, and you can use exceptions to respond properly to like an end of file condition and stuff like that. So we're gonna look at that later. So once you kind of work through all these design decisions, then you can actually kind of write a condensed form. Yeah, question? Well, yeah, the way exceptions work is you're familiar with when you run your program and you try to refer to a method of an object that you haven't defined yet, you get a null reference error, right? That's an exception that's thrown. And the reason the program halts when that happens is because you didn't write any code to handle that exception properly. You didn't write an exception handler. Yeah, it just halts. It basically stops, and you have to basically start all over again. But if you know how to handle exceptions, you can write exception handlers in your code so that the program doesn't stop. If you expect that things could go wrong, an exception handler can catch those events and respond gracefully to them and keep on working. So when we work with files, we're going to show you that in a few weeks. It's kind of hard to understand until you actually have it in front of you. But no, you're not going to worry about that right now. Yeah, it's going to come up in a later lab. I think when we do lists, which is not that far away, but coming up. Yeah, lists are very similar to arrays, but they're stored differently. Well, yeah. Anyway, yeah. Both, the thing is, when we actually implement a bag, you can use an array to represent a bag, or you can use a linked list. And we're going to study those things starting next week. Yeah, yes. Yeah. But don't worry, we're going to cover those in much more detail later. So anyway, so this is another way of identifying, and it's a compact notation. We haven't actually coded up the class yet, but we actually started to identify the kind of operations that the bag class is, and we've decided what the name of the methods are all going to be. And this is not any particular language syntax. This is not Java that you're looking at here. This is actually a format for what's called a UML, a Uniform Modeling Language. diagram for a class, which again, it transcends Java or Python or C++. You can write this class and not worry about what language you're going to write it in. And that can be, again, it sort of frees the developer from thinking about the details of implementation and lets them just sort of get still stuck in that design mode, which helps them kind of lay out the whole class. So here's our add method. You can see the add method is going to take a new entry of some type t. This is a placeholder for the data type. And it's going to return a Boolean. The format is all different. The name of the parameter variable comes first, and then its data type. And the return type comes last. It's kind of the opposite order for our method. But this is sort of a uniform modeling language that's distinct from actually any programming language. But these are all the methods that we'll be writing when we implement our bag class. Yep. Well, we'll talk about that, but these are an example of overloading. So you have two methods, good either. You have two methods named remove. One of them actually has an entry that you're trying to remove. The other one doesn't have anything at all in there. So the first one will just remove any item it'll just remove any item at random from the bag. Theoretically, I mean, there's no specification about which item it actually takes. And the other one is going to remove a specific item that you want to remove. Yeah. Yeah, you can get the frequency of, get frequency of is going to tell you, it's really should say like get count of. It tells you how many items of a particular entry are in the bag. And contains is going to return a Boolean whether this thing represented by an entry happens to be in the bag at all. So that's just true or false. Yeah, frequency returns an integer. So if you add 5 candy bars to the bag and you ask for the frequency of the candy bar, it's going to return the number 5. Yes. The Boolean represents whether it was actually able to add something to the bag, or in the case of remove something from the bag, right? That's the way we handle unusual cases. So when you're using the add method, and we're going to kind of go over all these. These are great questions, but you're all sort of looking ahead, and we're going to get all these things answered in the course of the lecture. But basically, you'll have to put, if you really want to use that feature, you would put the call to the method in an if statement. Because that way you can respond when it wasn't successful by doing it something else, right? So if you try to add something and it returns false, then you know maybe it's time to stop adding stuff to the bag because it's full, right? You should maybe do something else. Yeah, so good questions. You guys are really attentive. That's great. And this is the Java doc for the bag class. Again, we're getting a little bit more like Java now. So we're taking it another step to implementing it. And this shows you how you use it. And of course, we're not implementing it today. We're just going to be using it today. And until test 1, we're just going to be using these classes. And then after test 1, we're going to be developing these things ourselves. So it keeps the insanity down. I've noticed when we try to do too much too soon, everybody just gets like, whoa. But now we're just using it. So just like you use an array list, now we're going to use a bag. And so these are the methods. The add method, you can see, again, this is sort of what it looks like. This placeholder t is a generic placeholder. It's storing, like in the case of a bag of string, it's like a parameter for a data type. So if you're making a bag of string, what does t actually have? What is t actually going to be keeping track of? What's t going to say? It'll say string, yeah. And you can think of it actually as, in Java, it's like it's just a placeholder for that data type. And what happens before the compiler actually compiles the code, it replaces the t that you use to define a class with string if you made a bag of string. And then it just checks to make sure you haven't violated anything. And if it's okay, complicated, it changes everything to object and compiles it. Anyway, Java does things a little bit weirdly, but I don't want, again, these are all going to be covered in time. the get current size, get frequency of, all these methods now listed in their Java form. To array, which gives you an array of objects of all the items, and a to string, which gives you an array of string. So a little bit about that generic type specification. You have to give it a data type. Well, you don't have to, but if you don't give it a data type here, then it defaults to the object data type, which is sort of like a catch-all for any objects that you can that you want, which doesn't discriminate between the classes that you might actually want to be putting in something. And that's going to be in the second part. We're going to talk about more in the second part of the lecture. So if you need a bag of words, you can make a bag of string, right? If you want to make a shopping cart like we did for grocery checkout, you can make a bag of item objects, the item class that you just wrote on Monday. And now the bag is only going to hold item objects. Pretty straightforward. If you want to add something to the shopping cart, maybe you want to add bread to the shopping cart directly, you can create a new item at the same time you add it to the shopping cart, right? So this is going to create the new item for bread, and then whatever that returns is going to be an object reference that's going to be added to the shopping cart. The add method can return true or false, so you could do the following. If the shopping cart dot add a new item of bread 2. You know how these things are more complicated, right? If you try adding a new bread item to the shopping cart, and it returns true, right, because the add method can return true or false, you could print a confirmation message that says the bread was added to the cart. Okay? You're going to love the drill problems the questions get, when you try to do something, you have to type a lot, right, to make it all work. So you're going to love those drill things. They're going to really help clarify things. It's adding it to the shopping cart, and it's returning true or false on whether it was successful. So if it was full, it's going to say, "Oh, couldn't do it," and return a false. So then you can have an else and just say, "Oops, couldn't add it to the cart," right? Could not add, right? So that's why we have these Boolean return types, return values from these methods. And remove is the same thing. Remove is going to return true if it was successfully able to remove something from the bag. But if it can't remove something, which would indicate what situation? If it's empty, can't remove something, it's going to return false. Couldn't do it. And again, if you just invoke the remove method by itself, the one that doesn't have any parameters, shopping cart.remove, it's going to just take any old item from the bag. You don't really necessarily know which one's going to come out. Although if you code it, you'll know which one comes out, but you don't really have to know that. You just assume that it's going to be any particular item. Bags don't worry about order. Suppose you want to know how many items are in your shopping cart. You can invoke the get current size method. Shopping cart.get current size will tell you how many items you have. What if you want to know if you actually have peas, right? That peas problem that we had to deal with, right? That was a challenging problem. Well, it's not so hard when you have a bag. You can say, got peas, and then shopping cart.contains. You have to make an object to do the comparison with, but this is a temporary placeholder object that you're going to look at and see if this object is inside the shopping cart. Now, this actually confuses a lot of people, and I don't know why. So I thought maybe I'd draw a little sketch here, because if you think about it, what does a shopping cart actually have? Let's actually, do I have any space? Well, here's a little thing on it, but people don't seem to absorb that. So I'm going to draw a little picture for you. And imagine that, your shopping cart is an object, and it's pointing to, and let's just say we're using an array to store everything in the bag. And, we've got peas, we've got bread, and of course there's prices with them as well. We've got salad or whatever, right? And raisins. So what the contains method does is it takes this object, which is passed to an entry variable, and it goes through each item in the array and checks to see if there's an equality of data between this object and this object. It's using the equals operator to check to see if there's a match between what you're looking for, say the target, and a particular item in the array. Just kind of like what you did when you had to write the code for the grocery checkout problem, right? You had to check each name in the first one, in the names array, to see if it had a P in it. You had to write a loop that did all that, right? That's what the contains method is. John?
But it's not going to compare the price.
Depending on how you write the equals method for the item class, right? It's going to use your, if you made the item class, it's going to use your equals method to figure out whether something's the same or not. Now, maybe you don't care about price. So your equals method for the item class could just be checking the name. I'm sorry, it's not what?
Because you're creating a new item in order to compare, even though you're not adding it.
It's creating a new item, and then it's adding it. Well, it's not adding it in this case. It's just creating an object that it can actually use to do the comparisons for you. And you don't have to, if you've already got an object already created, you can just pass that. But yeah, it's just, this is just a reference to an object, which I happen to use just to make this example specific. It disappears afterwards because you're creating it. This is the weird thing. You're creating this object inside the argument list of a method call. So that object is created, but it's passed straight to that method. And when that method ends, the object just disappears. Yeah, it's not, there's nothing to hold on to it. It's like a local variable inside the method, but you're creating it in the argument list. Yeah, good questions, yeah. I can tell you're all going to be on LSD in a few years, architecting some really high-powered software projects. Yeah. I do not condone the use of drugs, just to be clear. Again, this is telling you in English what I just said, but for some reason, this doesn't really register for a lot of people. It's actually traversing the internal array, if it uses an array, using a loop, and it returns true if there's a match in the bag's internal array that matches the target, like it had P's. How do you know if there's a match? Well, the class of the object we're storing has to write a properly written equals method. And by the way, the equals methods that you wrote on Monday for the item class was not properly written. And I'm going to talk about that in the second part of the lecture when we talk about inheritance and why it was improperly written. It worked on Monday, but it won't work today. So if you try to work ahead, after I go off and check with the curriculum committee, you might run into a problem, and you could ask Ben, and maybe he'll tell you. But I will explain it all after I come back. Oh, actually, no, I'm going to explain it all right here. At least I got your attention. So this is probably how you wrote the equals method for your item class on Monday. You might have said something like public Boolean equals item that. And this is a placeholder for the argument, right? You want to check to see if the host object is the same as the argument. And you can say if this dot name equals that dot name, that's kind of a cute syntax, right? If this is the same as that, because the names are strings, you got to use the equals method to compare strings, right? And this dot price equals that dot price. Why did we use equals here and equals dot equals up here? Yeah, strings need dot equals because they're objects. Primitives needs equals because they're primitives. That's how you check the quality. So if both of those are true, you might say that's equals. And that would actually have worked on Monday, but it won't work on Wednesday because the bags contain method needs the official definition, which we haven't been following yet. Because if you define it differently, you're overloading the equals method, and you're not overriding it. You're not. Anyway, yeah. So here's what it's supposed to look like for the item class. Instead of actually receiving a variable of type item, which is what the parameters defined in the sort of naive definition, you actually have to use the word object, which is the granddaddy class of all, or grandmama class of all objects in Java, that all objects implicitly inherit from, whether you actually say it or not. So this is a more general form of the equals method that will work in all circumstances. And what you do is you're checking to see, because an object is an undifferentiated object, a capital O object, which is really confusing why they said object, right? Because it's a class called object. Is that confusing or what? They made a class called object. So what is an instance of an object? A lowercase object, right? Yeah. This is why you have to do LSD. It's so complicated. Ben just automatically goes, Ben is, he's on something all the time because he's really smart. I know, they're going to be suing me left and right, no, or reprimanding me. Maybe I won't post the video. I'll just post last year's video. So what you do though, because other is an undifferentiated object, you have to figure out whether it's the right, first of all, if it's not, if you're trying to see if an item equals a string, the answer right away is it's just false, right? Items just are not going to be the same as string, right? Because they're two different kinds of objects. So you can check to see if other is an instance of an item class, right? So if it's not, you just say false, it's not the same. If it is an item, then you're going to cast it. This is a cast, just like we were casting, doubles and integers and everything. It's safe if you know other, which is an object, is actually a item, you can cast it to an item variable of that. And then you can do the same comparison that you did before. That's the correct way to do the equals. So you can work ahead a little bit. Okay, and I will give you more information in the second part of the lecture on this whole object class notion and why that applies. There are some little quiz questions here, which I kind of like to just, so we'll just kind of look at them really fast. Question 1, suppose a bag represents an empty bag that has a finite capacity. Write some pseudocode statements to add user-supplied strings to the bag until it becomes full. That's an interesting notion, right? If a bag can only hold a finite number of objects, you could write like a while loop that just keeps adding something to the bag until it fills it all up. You could fill up the bag with candy bars, right? And I think that's one of the things you're going to do in the lab. And it would look something like this in pseudocode. You can use a do while loop. Do, get some string. In this case, it's a bag of string. Get a new string from the user, and then add it to the bag. While not a bag dot is full. And again, this is sort of the cool part about working with these things, because this is almost readable English, right? While not a bag is full is a way of saying, well, the bag is not full, right? You can almost read this without even thinking about code. It's very transparent. Yeah. Mm-hmm. Yeah.
I think the idea was like it's do while loop and saying put in this string, add this string until the page was no longer empty.
Yeah.
And then
until it's no longer full. Until it's while it's not filled. While it's not full. Yeah. While it's not full. Yeah. Until it's no longer empty is only going to be one time, because once you add something, it's no longer empty. So it sounds like you already did the lab. Oh, okay, good. Yeah. So don't spoil the fun for everybody. Yeah. Yeah. No. Shh. Okay. Question 3. Is it legal to have two versions of remove, one that has no parameter and one that has a parameter in the same class? Is that legal? Yes. Why? Or how? How does that work? What's it called? When you do that, there's a name for that, right? There's a name in computer science for that. It's called overloading. When you have two methods that have the same name but different parameters or a different signature, overloading. Given the full bag you created in question 1, write some pseudocode that removes and display all of the items, all the strings in the bag, right? Pseudocode again. Pseudocode says while not a bag is empty, right? And what that means is while the bag is not empty, go ahead and remove an item from the bag and display it. So that's going to be a structure that will just go through and display all the items in the bag. That's a lot easier than writing a for loop that looks at all the items in an array in general. So again, these are sort of nice tools. Once you have a bag object, you can use it in ways that make your coding a lot simpler than working with an array. And full bag, maybe you want to know how many times the word hello appears in the bag. So you can use this get frequency of and hello. How come we didn't have to say new string of hello right here when we said get frequency of? It's built in. Strings are special. Yeah. It's built in. You don't have to use that. When you say something like that, it really turns that into this, right? We had to do that, and you'll have to do that if you're using an item or some other class that you've written. But strings are special, and they automatically will be created for you if you do that. What are we doing here? Write some statements to display all the strings and don't alter the contents. That's actually a good thing, because the problem with this one is that in displaying all the items in the bag, at the end, you've emptied them all out and you've lost them all. So you've destroyed the bag while you decided to look at it. And maybe you want to display that as without destroying the bag. That's what the purpose of the toArray method is for. And weirdly, though, the toArray method only returns all the objects in your bag as capital O objects. So this actually doesn't work. This code here has to actually say capital OBJECT object array. You get an object array from the toArray method, not an array of the data type that you made your bag out of. There are fancier ways of dealing with that, but in this class, we're not going to be looking at those. So you have to deal with them as if they're objects, and you could try casting them all, but then, yeah, anyway, it's a little cumbersome. So finally, just as you, if you've gotten to this point, you kind of know a little bit now how objects work, and a good model for them is like a vending machine. Vending machines are predefined to perform certain tasks. They have an interface panel here. These are kind of like the methods of a vending machine. And so when you want to buy something, you press a button, like invoking a method, and then it spits out the thing that you want to buy. That's like the return value of the method, right? And the user only needs to know, like, what happens when you press this button, which candy bar is going to come out, right? The user doesn't have to know how the thing is actually built. And for today, you're like the users of the vending machine. After test one, you're going to be making your own vending machines, okay? And but the thing is, the vending machines, everyone can use them. Nobody's going to starve because everybody knows how to use a vending machine. And it kind of makes your life easier not knowing it, except when you buy something and it hangs up there like halfway and it just like sits there and it doesn't come out. That's really annoying. Okay, so now you can do 2A problems 1 and 2. And then I'm going to, and just as a final thing, there is a Java class, and we're going to touch on these things as we go. The bag class is sort of a unique class from our textbook. And after you graduate, you may not, there isn't really a built-in bag class in Java, but there's a set class that's kind of like a bag. But the set class, it lives in this library here. The difference between a set and a bag, though, is that sets can only contain unique entries. So if you do add multiple candy bars into a set, it's only going to show that you got one. You're only going to ever be able to hold on to one occurrence of a particular object. No duplicates. But other than that, the methods are fairly similar. Notice there's a Boolean return value for the add method. There's a Boolean for the remove method, and contains method, and yeah, they're all, so it's sort of following a pattern that Java obeys for most of these container classes. Okay, so I'm gonna stop talking and let you work on problems 1 and 2 for the lab. So you can download the starting zip file. Oops, that's homework. Go to lab. go to the lab and download the part A instructions are here, and the starting zip from this link here. Now this is the first occurrence of a class where it's precompiled. So if you're using a non-BlueJ environment, you might have to go searching online for how to add a precompiled class. I did this a while ago, and I sort of regret it. I should just give you the source code. But the thing is, I figured, well, we're going to be writing this. And so I'd rather not give you the source code for the bag class so you don't have anything to cheat on. But in fact, the PowerPoint slides when you do this are going to have the answers anyway. So I could just put it in there. I probably should make it a little bit easier for us. But anyway, I kind of want to keep that vending machine model where you don't necessarily know what it looks like inside the bag. You're just using it as a user. So if you click on package.bluej, you should open up BlueJ to that project. And this is the lab. And if you compile it, this is the way it looks. And you have this bag class, but you can't really open the bag class because it's just it's a precompiled file. It's just the compiled version of the class. There's a person class, which we'll be using later, and a student class, and a club class. And if you open up the lab 2A file, and let's check out the lab handout. Usually I have some kind of a visualization thing first. Do I do that today? Let's see. Oh, I'm gonna do a little demo for you first. This is actually probably pretty helpful. These generic type specifiers are a little confusing, and when we is everyone ready? Does anyone have any problems getting this thing open? Did anybody try to open it without extracting it? You know how to do that now, right? So it should be you should be able to compile it. It shouldn't give any weird error messages. It compiles okay. And then when you open up Lab 2A, let's do this demo 1, put a slash in front of demo 1. And this is sort of the wrong way to create a bag object. Notice we used the bag object, but we didn't say what we're going to store in it. So it's an undifferentiated bag. It's a bag that will actually store anything. So you can add a string to the bag. You can add a caret to the bag as a string. And you can add a number, not a string. And you can add John F. Kennedy to the bag, which is a little weird. No, it will do it. And you can print everything out. So when you run this, you can see the result. And unfortunately, the person class doesn't have a toString method, which maybe we can fix that right away so we can actually see John F. Kennedy there. But you can see all the data comes out okay. Should we write a toString method for the person class? I think that might be a good idea. Let's do that. The toString method, just going to say, you know, public string, toString. And we're just going to return, I think it's just a, this is a really dumb class. It's just a wrapper for a string, right? It just holds a string for the name, and there's a, you know, set name and a get name. The point is, it's really just helping us learn how to work with objects. So you're just going to return the name for your toString method. And now when you run it, You should see John F. Kennedy coming out of the bag. And now you might say, is anybody thinking, well, what's the problem? They're all different types, yeah. You know, there may be some circumstances where you may want to do that. But in general, you know, although you can put anything you want in the bag, when you start taking things out, they're coming out as objects and you don't necessarily know what they are. You could write a bunch of if statements to see if it's an instance of this or an instance of that and then process it differently, but then that's kind of a pain too. And in general, what we're doing here is the whole reason that we're using generics is kind of like it's a sanity check for us as we're coding it so that we don't accidentally put John F. Kennedy in a bag that's only supposed to hold strings or something, or we don't put a name or a double in a bag that's only supposed to hold strings, right? So if we now say bag of string, oh, by the way, you know what, this is kind of weird. Because it's supposed to say, is anybody getting this error message? Lab 2A, Java uses unchecked or unsafe operations. Is anybody getting that? Who's getting that? Are you working on your own computer or on the school computer? Why is it only happening to some people and not others? That's weird. I'm compiling it without any warnings, which is odd. Oh, maybe I'm just not seeing them. Maybe at their bottom. No, it says no syntax errors. Sorry? You got a pop-up? Yeah, that's what it's supposed to do. Mine doesn't do that, which is weird. Gives an error when you try to open the bag class? Yeah. Well, you shouldn't ignore it. If you do see this message, that means that you aren't using the generics properly. And this one's easy to find, but eventually it might be a little bit harder. But it's worth the trouble because the generics are it's a safety strategy. It's a checking. It's allowing you to check your code. And if you're not using it properly, then you're not getting those checks that you might want. So if you do have that error message, this will make it go away. You put string here in greater than or less than symbols, and then you say new bag of string as well. And now you're specifying the data type for the bag, right? And now when you try to compile it, this is why we want the generics. It says error found in class. I like it when this thing has sort of changed a little bit. Where are the errors? If I click on errors, there we go. You click on errors, it says incompatible types double cannot be converted to string. So this is a good thing because it turns something that might have been a problem later, like in runtime. You know, since we were able to add all kinds of things to this bag without specifying its type, the problems would usually occur later when they're harder to find. This actually is letting our compiler check to make sure we didn't do something we didn't intend. So you might say, oh, I didn't really want to add the number 3.45. I wanted to add the string 3.45, right? And oh, I didn't really want to add the person John F. Kennedy. I wanted to add the string John F. Kennedy. You can do these as strings, right? But you can't do them as mixed types. Now it will compile and run, but it's also ensuring that the bag only is going to hold strings in it. So the moral is it's okay to put John F. Kennedy in a bag as long as it's a string John F. Kennedy. Yeah. Well, the weird error should go away if you put bag of string. But you've actually gone ahead of us, so you might be having an error somewhere else. Yeah. Okay, so that is the demo, and that explains why Generics are good. Now you can do problem 1. Create a bag object, add these strings to it, and print it. You should have 2 soups and 2 apples. And by printing it, I think that means there's a toString method. In fact, there is a toString method for the bag. So you can print the whole contents of the bag just by printing out a bag. System.out.println a bag will print all the items in the bag for you to look at. And it won't destroy it either. It's nice. So problem 1 and problem 2. Problem 2, you're going to use a bag to represent a club of persons. So yeah, you're just going to play around with these things. And basically, problem 1, you're going to try all the different methods. And in most cases, you're going to say something like, some message, and then call this method to check. So that you can tell which one you're checking and know that it's giving you the right answer or not. And then you're going to play around with these different ways of writing the equals method. In fact, I think in problem 2, there may be an equals method already defined the wrong way. Let me see, is that true? No, you're going to write an equals method, and I want you to write the equals method the wrong way first for problem 2, so that you can see that it doesn't match. And then you're going to write equals the right way using that example in the lecture slides. And maybe I can leave that example up here so you can just refer to it up here. This is the correct equals method, which I'll leave up while I go run to the meeting and just sort of check on it really fast. Okay, any questions before I head out of here? Not until after I get back and give you the second part of the lecture. Yeah, so you should just be able to do problems 1 and 2, and if yeah, I'll do 3 and 4 when I get back. I'll help you with the other ones after I get back. Yeah. Okay, I'm going to pause the recording. Oh, there's a question here. Chat. A syntax error in the code you provided. For which problem? Well, I'll let Ben help you with that one. Oh yeah, not T here. Yeah, you got to do object of T. Thanks, Ben. T is just a placeholder for internal to the code for the class. And so like on the Java doc, you're probably, we're thinking about this Java doc that showed T there, I think. Or did it show T there? I can't remember. I think I might have said. Oops. Yeah, no, actually the Java doc says object, but it should say object square brackets here. It shouldn't actually say object. It should say object. You actually have to receive the items from toArray in an object array like that. Those are square brackets. It's my phone. Yeah, anyway, I could just leave the recording in case you have something to tell people too. This is the correct equals method, though I'm going to leave that up in case you get to that point. This is the pen in case you want to write on something.
I promise. I almost promise not to write anything. Yeah, exactly.
Move. You made that promise. You didn't promise anything for anyone else.
Exactly.
Lighter's quick.
No, that does. My first time in charge. There's a be very bad. Oh.
You're a computer science major at CSUMB?
Yeah.
You graduating this year?
Next. Yes. Okay.
Kind of.
Man, there's too much time.
So
I don't like time.
So trying to make sure there's no last minute class saying, oh yeah, you should
Yeah,
take this like
yeah.
2 weeks ago, and you're like,
I'll graduate next month.
good luck, man.
What's your dream job after you graduate?
I'm not sure yet.
When you go for your master's or just your bachelor's?
I think your bachelor's is pretty good after that, right?
We demand answers. For those playing at home, I shrug.
You must ask how old you are?
28.
28? Okay.
Take good luck. I don't have to be like gone at
You ever worked in a software development position anywhere?
Yep. I was the only
What company do you mind me
that
asking?
it started a system.
Would you turn that around when you were much younger, like 15, you said? Didn't you say you were turning that around when you were 15?
No, that was a year ago now, actually. That I stopped. I was here when I was like 16, 17. So,
Oh, it is. Oh, cool. Oh.
Especially when you go off on a tangent on how to be drugs and see their programmer. That's always the best part of classes.
No idea what's wrong. This is like, you must take LSD so you can understand the chip today. I'm like, wouldn't that make it more complicated because you're like, doped up? He's like,
No,
it sticks out opposite.
it's happening.
But it's so complicated, it becomes simple. You're so doped up, they can make more sense.
No.
Still think it's funny.
so anybody running into trouble?
I'm a little confused on,
Okay.
define and test the intersection method below.
I don't think we're there yet. Nope. So, hold on. I don't think he's defined what the intersection method even would be.
Oh, we're not dealing with anything now.
Yeah.
Oh.
I mean, you can try, but
Okay.
you may have some trouble with that.
Did you, we have to do how, did how did you talk about, users? Oh, it doesn't have to be allowed, I mean, I was just trying to keep up. It's kind of like that.
And yeah.
Mhm.
I asked him if we need a number, and he said,
Well, I hope we, yeah.
Getting some help for seeing what I did for the grocery checkout.
That's just kind of,
she does not care about him in that regard. She does not care about him in that regard.
hold on, I'm just trying to just focus and hang out. Yeah. No, if he doesn't want to keep on rolling.
You're not sure how,
I mean,
because you declared an item.
Something that's.
So, you don't think an item.
What about my
Like, that's an item, right?
but how do I use?
Questions?
Will you use what to like item refer to?
Okay, so we're going to be quiet while I lecture. And this stuff is actually something that's really complicated. And it is in Appendix C of the textbook, at least the third edition. I think it's not picking it up. Third edition. And it's on these slides, but these concepts are very ethereal, and you have to really focus to really get what I'm saying. So I really recommend that you don't try working on the lab right now, but just bring your attention up here. And then, yeah, you continue after that, and you can get as much done before we leave. And then if you do have questions, I am online Sunday night. Did you all get my email when I told you about my office hours for Sunday night? Yes, so you can tap in at that. Every Sunday night from 8 to 9. And get help. And I can actually see your code, like Vaughn just shared his screen with us over the conference line, and Jacob was able to help him get unstuck on an IntelliJ problem. He's using IntelliJ for his coding. So anyway, the thing about this chapter is how you create classes from other classes. It's not just about inheritance, but inheritance is the biggie. We're going to look at other ways called composition, and you're going to demonstrate all these in this lab too, I think. Did we do inheritance in this lab? I can't remember. I think we have. But if not, you're going to do inheritance in homework 1. And there's a lot of concepts from inheritance that just sort of work their way into Java in general. So we're going to start with inheritance because it's the trickiest one. And again, these are ways of making classes from other classes. So, and the point of this is to actually reduce the amount of code that you write so that you don't have to keep reinventing it. Inheritance inheritance is the most, I think, popular way for many circumstances, and it's the way a lot of complex projects are developed. With inheritance, a general or base class is first defined that has just a few of the features that you're looking for, and then you develop more specialized classes by adding more details to the base class. And in each step of inheritance, you're able to access all of the ancestors code without writing anything else. It forms a chain that you build on, and it saves a lot of work. If you design things properly, it makes everything work really effectively. And then you can, if you have to modify things, you can modify the base class, and when you recompile everything, it gets all those modifications automatically. So it really makes it easy. And that way, you only have to define certain properties and behaviors once for all the classes involved. You don't have to keep reinventing the wheel. A good example of inheritance, like if you are making a bunch of classes that do things, you might, like classes that involve transportation, you might start with a general, very abstract or very simple vehicle class from which you inherit all the properties of that to make an automobile class, which is more specific, and then maybe a car class or a truck class. And each one of these is getting more and more specific as you go down the tree. But each one of these is picking up additional features that you'll be coding and testing as you do it. Inheritance embodies an is a relationship. You can only use inheritance to develop a subclass if the subclass is an example of the parent class. So an automobile is a vehicle, right? A wagon is a vehicle. A sailboat is a boat. A truck is an automobile. A truck is also a vehicle. So these inheritance relationships have to be sort of linguistically justifiable. You can't say that, you know, an item is a string, right? That doesn't work, right? An item is not a string. So you can't use inheritance to develop an item from a string class. It wouldn't be appropriate to do that. I mean, you can do some of these things, but you shouldn't, because it's going to be really confusing if you do. The hierarchy looks say a hierarchy of student classes. Maybe you have a student, a generic student, then you have more specificity for schools and middle schools and grad students and so on. You have college students or whatever. To access the inherited fields, in general, you don't get access to them within the definition of a method from another class, even if it's a derived class. But they are inherited, and so they're actually internal to any inherited object. So when you make a school student, if there's any variables like a name that's defined in the student class, a school student has a name as well, because it's inheriting that name field from the student parent of itself, right? So, but you can't refer to it directly with the regular access given, and because private methods in a base class are also unavailable to the derived classes. But usually that's not a problem, because there may also be methods that can work with those. So here's an example of deriving a student class from a person class. And I guess you're using, that's why you're doing the student class. The student class you're going to create is going to be a subclass of the person class that's already provided for you. Yes. The keyword is extend, yes. Yeah. Mm-hmm. Just wait. You're asking questions that I'm going to talk about like in 2 minutes. Yeah. Okay. So hold your horses. And you're probably trying to get oriented, but yes, that is the technique to do it. And you're going to see some examples. Okay, here's a person class. This person class has some features. It's a very basic, it's basically a name, a wrapper for a name, right? And we wrote a couple things for that. And this is the student class. And you're going to refer to this for problem 3 because you're going to inherit a student class from a parent class. And in fact, there's a lot of stuff provided for you. You can use as a reference. But now a student class has extends the person, which means it has a student is going to have a name as well, right? But it's also going to have a student number, an ID number. And you have to use the extends command to extend that from the person class. So extends is the keyword for meaning that you're inheriting, it inherits from person, right? That's what extends means. Okay, so how do you do constructors then? Well, the student constructor is going to need to invoke the parent constructor because the person constructor has to be invoked as well. Now, you can invoke the person constructor by saying super. And so the default student, which is the NOR constructor here, is going to have a name of what? Can you see that? What's going to be the name of a default student? It's going to be the name of default person, which is no name yet, right? But the explicit constructor for a student, which takes an initial name and an initial student number, will invoke the constructor of the parent with a parameter, and that invokes the explicit constructor of the person class, right? So that's how it gets an initial name, right? So this is going to allow you to initialize a student with a particular name and a number. You can also get the student number. You can get the student, set the student number to something. And you can also change the name of a student because all of these methods, set name, get name, are available for students as they are for parents, for persons, sorry. So that you can, you have the extended capability, yes.
Student, it doesn't say this name, this dot name is equal to this new name. Because you know when you say you're gonna set a name, it says this name is equal to this name is equal to name or something. Like,
That's because the variables are named differently. So this is called initial name and this is called name. So you don't have to say this dot name equals name because you have a different name for your parameter. When they have the same name, yeah, when they have the same variable identifier, when they have the same identifier, then you say this name, this dot name equals name. Okay, what about the toString method? The toString method for the student class needs to invoke the toString method for the parent class. So it says super.toString. That gets the string version of the person part of a student so that you can add it to the student number, right? So that's how you actually can, you can access those parent methods inside the child class. And then the equals method for the student is going to check if it's an instance of a student. And then you have to first check to see if the names are the same. This is going to do the equals method for the person class and compare that to this the student object, and if the student number is the same. Very, very complex. So you're going to use this as a model, and this will help you. In fact, this is doing a lot of it for you. You just have to kind of type a lot of this stuff up. And then demonstrate it that it actually works. Mm-hmm. I'm using super, and how does that apply to two variables of the same type? What are you talking about by two variables? No, super is referring to the parent class of, sorry? Uh-huh. But super is not a string. So actually, that is kind of confusing, right? What is actually, instead of super in this case, you might think everywhere you see super, you might plug in the word person. Not literally, but what does super actually represent? When the student is defined by extending the person class, super is a reference to the parent class of the class we're defining, and the parent class of the student class is person. So super is actually referring you to the parent class. So when you say super.toString, that's referring to the toString method of the person class. Super is not a string. Super is a reference to the parent class of the child class. When you say super parentheses,
Yeah.
that refers to the constructor of a person. Yeah.
So it's kind of like, when you use the word this, it's talking about the current class, you can use super kind of like that, and it just whatever you love it.
This is not talking about the current class. This is talking about the object, the instance of the class that you're looking at. Yeah.
Okay, so here's,
I know these are really subtle, and it is challenging to wrap your head around it.
if there's something in here, and then something here from that, how would you access the
Yeah, how do you go 2 levels up?
Yeah.
I don't know. I don't know if you're supposed to. I think you might just supposed to be going 1 level up because everything should be provided for you by the previous one. If you know what I mean.
Yeah, so like, the second level down, access something from the one above. that
Yeah.
one should access-
I don't think you can say super.super, but if you want to experiment and let us get back to us, you can. John? Yeah, make sure each version has a 2 string and then you just go up 1 level. Yeah, but I don't know. I'm not a, you know, I'm not whoever developed it. I'm not, who invented Java? Some guy. Some guy named Jay.
The super person class have 2 private variables that are not, that are going to be inherited from
Yeah.
lower class. You would do super dot, say, person have an identifier, super dot set ID.
You can't, no, because, yeah, you can refer to all the methods, right? You just say super.setID, yeah. But you can't refer to like the field if it's private of a super. So like you can't say super.name, even though person has a name field because it's private. You can never say super.name equals Joe. Or Jane, right? But you could say super.setName and then change it to something else using the method.
So maybe super dot set name equals dot.
What?
Would that be the?
No, you can't say setName equals. SetName is a method, so you have to give it a parameter.
Oh, and then inside that.
Yes.
Oh,
Yes. Yep. Okay. All right. Question? You guys are gonna ask me so many questions that we're not going to get through the lecture, right?
Well-
That's your plan. You don't want to actually do any more work today, so you're just going to delay me. Go ahead.
I'm gonna, well, first of all, like I looked it up, it's James Gosling.
Cool. Awesome.
And 2,
Someone who became eminently famous after doing so. I wonder what he's doing now. He's probably retired.
and also just to clarify, it's like you wouldn't do anything if you put super, if you used super in a class, but it wasn't extending from anything. Like it wouldn't go super to object class, right? It wouldn't do anything.
Well, yeah, if you're not inheriting anything, then super would refer to the object class. Because everything automatically inherits from, so actually, if you don't inherit from anything, like the person class is a subclass of object. And I'm going to talk about that later too. So you're all asking me questions that if you just wait, you'll get your answer, okay? Jeez. Great, I have an update from Malwarebytes. I feel safer now. Okay, so again, this is just summarizing some of the things we're doing. So invoking constructors within constructors, constructors initialize data fields. In a derived class, you have to call the base class constructor. You have to, and you have to use the word super to do that. And it has to be the first thing you do in the constructor definition. That's also important to know, right? You can't do it second. You have to do it on the first line of your constructor for the subclass. And you can't say person here, right? So you have to say super. Even though you're inheriting from person, you can't say person here, even though that's what super really means. Okay, then you can override methods. That's when the derived class defines a method with the same signature as the base class, has the same method name, the same return type, and the same number and types of parameters. And is there an example of an overridden method in, I've got so many things on here, let me just erase. Yeah, so toString is an example of a method that's being overridden, because there is a toString method in the person class. Well, we wrote one. There isn't one now, but there will be. Yeah, this is assuming there is one. It doesn't show it in the previous slide, but assuming there is a toString in the person class, the toString in the subclass is the same. Yeah, that's an example of a method that's overridden. How about another one? Equals. Yeah, the equals method is going to be overridden as well, because this is the same pattern as it is in the person class, which I think you've done already. Okay, that's overriding. Objects of the derived class that invoke the method will use the definition from the derived class. That means if you invoke the toString method from a student object, you're going to use the student's version of the toString method. If you invoke the toString method for a person object, you're going to use the toString method for the person class. And it is possible to use super in the derived class to call an overridden method of the base class. That's what's happening here. The toString method is using super to invoke the equals method for the parent class. Or the equals method is, here it is, this toString method is doing it right here. So this shows it also, if the class student has a toString method, and maybe college student has a toString method, and maybe in the client class, you're making a college student and you're invoking the toString method, that's referring to this guy, and this guy is invoking its super method, super call, so that's calling the student one, and it'll all sort of change together. Yes. Is what because of a college student object? Yeah. No, the overriding takes place in the definition. So the developer who wrote the toString method for the college student overrode the toString method for the student class. The client class is just invoking the toString method for the college student. The client doesn't do any overriding. Overriding is actually set up by the developer of the class when they design it and they decide to make a method that has the same name as a parent class. Yeah, isn't it funny how you? This is why these things are so convoluted. You can come up with a really wrong idea looking at this pattern. These patterns. It's real easy to do, right? You can have a completely wrong idea, and that can take you off in some weird tangent. So there's only like a handful of people asking questions. The other 90% of the class, you could be off in Never Never Land, and you won't know until you actually try to code. Right? That's where it actually shows up that your ideas are wrong. So yeah, I welcome any questions, although we do have a time limit. So, and it's nice to get a question from a variety of people. Oh, so there's a difference. This is showing the difference between overriding and overloading. You might have be familiar with that. We did an example of overloading already. When was an example of overloading in part 1? You saw that in the bag class, right? What was an example of overloading in the bag class? Yeah, the add method. There were 2 different add methods, and there were 2 different remove methods. They had different parameters, right? That's overloading. Overriding is when they have the exact same signature in the parent class and the base class and the subclass. Yes.
So when do you use that? The at symbol and then override?
Yeah.
When do you have to specify it specifically?
The at symbol is that's just a Javadoc formatter. It's just telling you in your notation that you're overriding. It's just a documentation thing. That doesn't actually override. The overriding takes place when your method name is the same as the parent one. Yeah, I don't think so. I think that's just a Javadoc. Ben, is that right? You can correct me on that.
I know for a fact that attributes can influence the compiler.
interesting.
I don't know exactly, like I haven't looked it up
Yeah.
in a very long time.
So, yeah, good. But you can write code like none of these examples are using the @ symbol to do any overriding, and the overriding is taking place. So the @ symbol is not required. Yeah, we all have so many ideas in our head. We don't know what belongs to what language anymore. So yeah, so overloading a method, same name, same return type, but different number of or type of parameters. That's overloading. Then the derived class has available the derived class method and the base class method with the same name. So that's the case where, like, if the parent class has a different number of parameters than the subclass, then you can actually refer to either one of them. And Java can distinguish between the two methods because of the different parameters. It'd be nice if they had an example of that, but they don't. So yeah, that's not hugely important. So object types of a derived class. Given class college student derived from a class student, then a college student object is also a student object. This is actually kind of interesting too. In general, an object of a derived class is also an object of the base class. And that has implications. So here's a question. If high school student is a subclass of student, can you assign an object of high school student to a variable of type student? Somebody says no, somebody says yes. How many people think yes? How many people think no? About 50-50. Well, it's actually about 10-10 because only a few people are responding. So yeah, that's what this is saying. An object of a derived class is also an object of the base class. This is sort of the rule of inheritance. So that means we have person and student, right? Can we say person P equals a new student? That looks illegal. Can that be done? Well, didn't we say inheritance requires an is-a relationship? So a student is a person, right? Can't you say that? And the language is actually set up so that the answer to that question is yes, this is legal. You can assign a student object to a person variable because a student is a person. And what that means is any methods that you try to activate from the person, P, right? So you could say P dot to string. This actually gets a little complicated because of binding and everything. But you're guaranteed, because a student is a subclass of person, it has all of the capabilities of a person, right? Because it inherited them all. A student is a person. So any method that you try to invoke from a person variable is going to be there in the object. The object is actually going to have that. But you cannot say student S equals a new person because why? The student class may have additional methods that the person doesn't have. So you might invoke something that doesn't live. It's not there in the person object, right? A person is not always a student, although a student is always a person. Yeah.
So like when you're declaring a variable, though, aren't you like also kind of assigning your memory spaces to B? So like if you're saying person B, then it only has kind of like memory spots for the instance variables of person. But when you're creating student, it might have like a student ID. Like how would it be able to, where would it fit?
So you're talking about memory storage, and that when you make a person P, that it's sort of reserving enough memory just for a person, and not for all the extra stuff that a student has. But think about it. All of these variables that we're storing, like P, is not actually holding a person. P is holding a reference to where the person is stored in memory somewhere else. And when you say new student, that's creating the student object on the runtime heap somewhere, and it's giving you the address of where that's stored and storing it in person P. And that address can go in any variable. Yes.
Why would you do a person?
Why would you want to say person P equals new student? Sometimes you want to do that. And you know, we did this fun example, and in fact, yeah, some CSUMB student last semester made an example code for me for my inheritance lecture in C++. And you know, you can make a whole inheritance thing of, well, even there's so many examples of why this would be good. So if you think of another example that I used to use in my C++ class talks about these as being maybe licenses, right? Maybe you have a vehicle license or just in general different licenses. Maybe you need a boat license and a wagon license and an automobile license for a car, and these are all different licenses. Now, it might be really helpful at some point to have an array of a whole bunch of different licenses. And so in that case, you could just make an array of vehicles or something. And then in that array, you can store objects of any of those subclasses as well. So you can have them all in one place, which can be really handy because they're all going to have the same core features. And there was another thought, but I can't remember what it was. Okay, question.
So does that mean, you could do like object in the name and then say equals person?
Yes, that's why object, a variable of type object can hold a reference to any object that you want, because everything is a subclass of object. Well, don't, but it actually happens when we write our classes using the generic thing, it all defaults ultimately to object. All the storage in these classes is object. So that's why, and you're leading me to my punchline, which was coming up. So I'm going to wait. Well, okay, I'll say it. That's why the equals method has to say object other, because that's what everything is defaulting to when you're using generics in these classes. Yeah. And I did this. I did. Oh, we're way beyond this. Okay, this. Yeah. So this is okay, and this is not okay. And I think there's going to be some explanations. Yes, you can assign object to the class to variable of any ancestor type. An object of type high school student can do anything that an object of type student can do. And can you assign object student to a variable type high school student? Yeah, no. The student object does not have all the behaviors expected of a high school student, so therefore you can't assign. That's why this is not legal. Okay, so here's this object class. All right, every class, this is the way the whole language, so obviously, what was his name? Gosling? James Gosling? He was on LSD when he created Java, right? Wouldn't you have to be? I mean, think about it. This is so convoluted.
Java 1.
Right. I haven't seen Java 1. So every class is a descendant of the class object. Object is the class that is the beginning of every chain of derived classes. It is the ancestor of every other class, even those defined by the programmer. And it's helpful to kind of look at what is included in the object class, because you'll see some familiar things in there. I guess Oracle changed its organization. So I will exit and just Google, Java object class. And I think it's probably here. This is the, this is the object class. And this is the documentation for the object class. It shows you the constructor, very simple. There's a default constructor, and that's all. Then there's some methods. Clone, which copies an object. Look at that. Here's the equals method, which takes an object as a parameter. Okay, and this explains why in question 2 you have to write the equals method with an object. Because if you write the equals method with a person here, what are you doing? You're overloading the equals method. You're not overriding it. And in order for this to work, you have to override the equals method for your subclasses when you put them in these bags and things. Otherwise, the contains method isn't going to work properly. There's a lot of stuff that we're going to get to later, like hash code. We're going to talk about that when we do hashing. A lot of stuff we're not going to use at all. But look, there's a toString method. But the toString method for object just returns the address of where the address that's held in the reference variable of where that object is stored in memory, or sometimes they call it just an ID code instead of an address. Wait, I don't know, yeah. So there's not that much that's, but there's a few core ones: the clone, the equals, and the toString.
You will never use them in this class.
No, you will not.
Guarantee it.
You will not use them in this class. Well, maybe Conrad will. He's got some big ideas for his final project. And I'll ask Ben to grade it because I won't be able to understand. So that is the object class. So it defines clone, equals, toString, among others. All classes automatically derive these methods from object. To be useful, we have to override those methods so that they work with the details of the class in which they're applied. So here we are overriding, back to overriding the equals method. The parameter is class object, and we're using a cast to be able to refer to it as a name or student or whatever. This is the equals method for the name class. And we can refer to the private data members of that since it is an object of the same class. So in other words, if we determine that the other object is an example, an instance of the name class, and this is the equals for the name class, then you are given access to those fields. So you can refer to the instance variables of objects of the same class. That's actually allowed. That's why we can say that. Y equals object other. Overriding versus overriding. Let's start with the difference between overriding. This is something I actually looked up on Stack Overflow. With overriding, you're actually redefining the method for the subclass, and you're removing its original implementation. So in the student subclass, if you invoke the toString method, you can't invoke the toString method for the parent. You're actually erasing the parent's version of it. And replace it. So when you do at override, so again, yeah, I don't think this is I think this is just for documentation, public boolean equals whatever. You're actually relinking your new equals implementation to replace the one object. On the other hand, when you do public boolean equals my class M, the way we were doing it in 10A and on Monday, you're defining an entirely new method because you're defining a method with the same name but different parameters. When contains calls equals, it essentially calls it on a variable of the type object. When contains, this is the contains method for the bag class. When contains is checking the equals, whether these two objects are equals, the thing in the array and the thing that you're checking to see if it's in there, it's using the equals that calls it on a variable of type object. And if you haven't written your equals method that way, then it can't possibly work. The contains method will not work properly. And it's very subtle because you're not invoking equals in that problem you're just invoking contains. Contains is invoking the equals method, which has to be written properly. Very complicated stuff. If Sue and Susan are two instances of a class name, what if statement can decide whether they represent the same name? Okay, the equals method, good. That was not very helpful. Okay, so that's inheritance. And that's how you make classes from other classes if they're related. But another way to make classes from other classes is composition. So composition doesn't mean is a. Composition embodies a has a relationship. So, like, if you are making a driver's license class, a driver's license usually has like an expiration date. So a license has a date in it, but a license is not a date, right? You can't say a license is a date because it doesn't make any sense, right? So when a class has a data field that is an instance of another class, that's called composition. So here we have a, I guess this is a student object, which has a name object and a string object. And student has a name and it has an ID. There is a student. Notice it doesn't say extends here. You don't need extends because you're not doing inheritance, but it has a name and an ID. This is the one, this is not the one we're doing because we're doing it with inheritance from person, but anyway. A student constructor may take a name and a string. And these are both objects of some class, and we're just using composition to create them. So an object of type student would look something like this with these different fields. And composition is a technique you can also use to write a new class that makes things look better. So in the lab, you're gonna, in problem 2, you made a computer science club that was a bag of persons, right? Which sounds a little morbid when you think of what a bag of persons. Are they dismembered or something? You could get arrested, but no, it's just a computer science club. So it might make it nicer to look at is to make a new class called computer science club. And inside that class, you could hide a bag of persons and then nobody else would see it. You carry your deep, dark secret around. Anyway, you can have so much fun with programming. Yeah, so that's called an adapter class. And that's what you're going to do in problem 4. You're going to make a computer science club that has a bag of persons inside. When you're using computer science club objects, you wouldn't know that it had a bag of persons in it because you're just using it. So here's an example of a nickname class adapted from class name. Inside a nickname object is a name object to hold the data. So here's the name class, which has all these different fields, and then members, and then here's a nickname. A nickname has a private name and a constructor that just makes a new name or initialize it to something. And a nickname is really just a single word. So a nickname is like a one-word name, like Madonna, right? Madonna is a nickname for what's Madonna's real name? Does anybody know? It's something Italian, right? What is it? It's like the Tico or something, isn't it? Somebody look it up. Ciccone or something. Yeah, it's Italian. She's Italian. So you only need one field for a nickname, but they're using the name class, which has 2 fields, and they're just setting the first name to the nickname because that's all you need. And the get nickname is just going to return the first name, and that's a really simple adapter class. You now have a nickname class, and you used a lot of code from the name class. It sort of maybe saved you a little bit, but this is just purely a demonstration. So now you can make a nickname Bob and so on. Yeah. But for 2A problem 4, let's write the use of an adapter class. You're going to make a club class as an adapter for a bag of person. So then you don't have to say bag of persons computer science club. So once you make that class, it'll just say club CS club equals new club. That looks a lot cleaner. But inside it, inside the public class club, you're going to have a private bag of person for all the members. And the constructor is just going to make a new bag object. And all the other methods, like isFull, is just going to activate the isFull method for the bag that's inside the club. So it's a real trivial operation to create an adapter class because it's using all the code that the source class is providing. This is not inheritance, because a computer science club is not a bag of persons, right? But it is using all the code for that as well. So you're playing around with all these different ways of representing classes. This is a really interesting lab. And then if you want some more challenge, you can write an intersection method to compute the items in common between 2 bag objects. This is sort of an interesting thing like a set would have. You might have an A bag that has peas, carrots, and celery, and a B bag that has peas, donuts, and celery. And the intersection of those two would be peas and celery, the ones that they both actually have. And the challenge would be to do this in a non-destructive way so that you actually don't, you don't modify the original bags in the process of creating the intersection bag. So there you go. And you have 20 minutes to do it all. And Ben left. Question? Yeah. Okay, I'll pause the recording. Sorry? Well, it was available, and some people already started it. No, I didn't change it, but we will. We may be experimenting with the online coding assessment that you already are familiar with. Yeah, so this is homework 1. And just so you might be curious what is in homework 1, it's kind of like a lab, but you're going to do it on your own time. And there are some coding bad problems in homework 1. It says February 25th. I'm going to remove that thing. Canvas, the Canvas due date is the correct due date. This is always from another semester. We start at a different time. But you're going to do some coding bad problems. It's kind of a review assignment, more practice that you get to do. And then you're going to make some classes that implement inheritance. You're going to make a general coin class, and then an actual actual coin class which inherits from a general coin class. Why? Just to give you practice with inheritance. And then you're going to flip about 50 of these things and store some of the head coins in an array. And the tail coins are going to be stored. No, the head coins are going to be stored in a bag, and the tail coins are going to be stored in an array. Yep. Yes, you have to use the keyword extends on a subclass. And then there's a challenge of Hydra simulation, which is using a bag to keep track of how many chops you make on the head of a Hydra to kill it. Hydra, when you chop off one head of a Hydra, 2 smaller heads will grow back in its place. So how many chops does it take to remove all the heads of a Hydra with so many numbers of heads? That is the question. And what's interesting is, so the ancient Greeks understood, they understood O of 2 to the n, which is what this problem actually represents, which is kind of cool. So that's homework 1. Okay, so everyone at least here knows that there's a homework 1. Everybody else I'll have to remind on Monday. And we're done in 3 minutes, so I'm going to quit the video unless there's any questions.